Good morning. Twinkle, twinkle, little star. Just doing a sound check. Good? Okay. Good morning, everyone. So I work with EY. For those of you who may or may not know us, we have 400,000 employees across the globe. We have a commitment of $1.4 billion of investment in AI. From a cyber perspective, we have 14,000 people across the globe, working across various member firms and our global delivery capabilities. And when we started on this journey of, capitalizing that investment part of 1.4 billion, what we quickly realized is we needed a better way of doing it. And what I'm going to share today is learnings from what we have seen, what works, what does not work. We fumbled initially with leveraging AI for cyber, and there are some learnings that we have achieved from there. Sorry, I don't have a clicker, but is there one? Perfect. That framework is what we call a SHIELD, and SHIELD essentially stands for strategize, harmonize, impact, enable, learn, and deploy. This encapsulates a lot of pain and blood and sweat which has gone in terms of learning about how do you do AI at scale and how do you apply it specifically for cybersecurity. And there were a couple of, I'm going to spend a little time on this slide because it's important to set context. So there were very specific questions that we were trying to answer. So when we started off, for example, on strategize, I think the main question that we were trying to answer is that what are the real problems we want to solve? And what form of AI do we really want to apply? Because there's a lot of hype. I think our partners from CrowdStrike also spoke about that everybody talks about Gen AI. But is Gen AI the answer to everything? And I think we want to unpack that a bit. The next bit was harmonizing. And when we started off, one of the problems that we saw was a vast majority of the use cases that we were identifying, and this is for internal deployments or scenarios where we were supporting or working with clients, started getting fixated towards the SOC, getting clubbed in that SOC. And we said, is there a better way of doing that? That was the second question. The third was about impact. What's the real value, and what's the real ROI around it? And measuring that is important because if you start on that journey without a very clear idea about where you want to land, that becomes, you wasted a lot of time, resources, money in that process. The next was about enabling. Now, as I've said, we have 14,000 people. How do we do this at scale? When I say at scale, how to do this in a more industrialized manner? What is that AI-ready cyber function, cyber capability that we need? What kind of training do we need? What kind of a culture do we need? That was another important question which bothered us for some time, and then we found the right answers for that through our experiences. And when we go down, and from the early phases of the use cases that we were pursuing, one of the things that we learned was we were failing quite a lot in the initial phase in terms of deriving value, and we were spending a lot of money and so on. And it's important that one big lesson that we took was that we need to learn from what works, what does not work. And lastly is about deploy, which is how do you take AI innovation, which might be 2 or 3 people collaborating on a specific initiative, and then put that out at enterprise scale. And we had to develop a method to that madness as well. If anyone has questions, please raise your hand. I'm happy to take some questions now, or we can take it at the end of the session as well. So let's start going into a little more of detail around what do each of these dimensions mean. I'll start off with strategize. I'll come to the use case part of it, but I think it's important to identify what problems are we really trying to solve and what form of AI should we be using. So if you generally look at the industry and what exists, you tend to see expert systems. These are rule-based, where there's a well-defined pattern to things. So that's typically where expert systems fits. Then you have supervised learning data, and data where you have labeled it, right? Because you're trying to discover a pattern, but you need to then have a label on that data. That's where you typically would use supervised machine learning. For scenarios where you don't have labeled data, which is very unstructured in nature, that's where you tend to apply unsupervised machine learning. And what we tend to see where the industry also started is focusing heavily on the supervised, unsupervised machine learning and so on, right? There's reinforcement learning. Reinforcement learning focuses predominantly on sequential decision making, and it's a bit of trial and error. There is no perfect answer. You have to discover the answer as you go about it, right? And I'll take a few examples of the use cases as well out there, so just to make it real for you. And then we have neural networks. Neural networks is at a completely different level of complexity, because there we are talking about using a combination of supervised machine learning, unsupervised machine learning, probably reinforcement learning as well, right? Or it could be using expert systems. So that's the reason why it's called neural networks, because it's got multiple layers. And finally, our favorite, I would say, is Gen AI, which has just exploded over the past 2 years or so. Now, what kind of problems? Let's talk about that a bit. If you think about unsupervised machine learning, and this may not be a scenario for you, but for everyone, but we tend to see when we work with clients wanting to identify who are my insider threats, who are my risky users. And for that, we use unsupervised machine learning as an example. For automated incident response, we have some scenarios where we apply the reinforcement learning, right? Because that's basically trial and error, sequential decision making, and so on. So moving on, the next bit was about, as I said, in the initial phase, we saw a lot of the use cases were very, very SOC-centric. And we wanted to find a very simplistic, easy to understand model, because we are trying to do this at scale at EY. And we leveraged the NIST cybersecurity framework, because that was easy, because that helped us ask the question every time ideas came to the table: are we building something as preventive safeguards? Are we building AI models for supporting the recovery function, and restoration function? And a few examples out here. If I start at the end, if you think about recovery, how do you decide? How do you predict what's the best way to recover? And what's the optimal order, rather? And that's basically a lot of pattern recognition, et cetera, as well, and analysis of the systems. You think about, I'll take a good example of preventative safeguards, where you're looking at understanding user access patterns, and this is a big use case that we have. We used to have a lot of people doing manual user access kind of tasks, and we have applied this very successfully to reduce the number of the amount of time that we need, and also the amount of money that we were spending in terms of some of these functions. So moving to the next one, impact. I think by far my colleagues at EY, and especially those who are part of the AI review committee and so on, we spend a ton of time on this, ton of time. And I think we spend the maximum amount of time out here is trying to understand what is the actual ROI, what is the value of the investments that we are putting in. There are 3 inputs which go into it. First of all is the baseline. What are we comparing against, right? And every time we find a scenario, it might be a cool idea, but you don't have a baseline to compare against, it's difficult to then say how much value you will really get out of it, right? The second dimension of that is around the success criteria. And here we're talking about improvements. Is 20% good enough? Is 50% good enough? Or should we actually be aiming at 100%, right? That's also another dimension to think about from a success criteria standpoint. And lastly, feasibility. Feasibility is a very big dimension of this because we have to think about, do we have the right data to start with, right? Do we have the right infrastructure? Is it going to cost us $4 million to build that scenario and the return on investment is just $1 million? So that decision making is very important out here. Now, and all of that goes into the business case analysis. What you see at the bottom of the slide is essentially an example business case. And this is what we would recommend if you're trying to do this in your own individual enterprises. If you can't boil it down to this simple statement, there's something wrong. You have to then go back and tell your teams that, hey, you need to do some more homework, and interrogate data enough so that you're able to come up with that business case. For example, this one specifically talks about if we are going to deploy AI-driven incident response, what is the investment going to cost? How much savings are we going to potentially see? What percentage of improvements will we see in terms of response times? And what's the ROI? And what's the payback period? Is the payback period going to be 10 years, or is it going to be like 6 months? And this is a very important area where a lot of the AI cyber use cases, where we spend a lot of time evaluating this. I didn't mention this in the beginning, but when we started off the journey, the 14,000 people, the wave 1, where we launched the initiative, we had 2,000 ideas. Are we going to fund 2,000 ideas? And we had to develop a method to that madness, and and this is across the globe, right? Every member firm had, and consultants and analysts across our member firms had a lot of those ideas. And we put every idea through this rigorous screening process before any initiative is funded, and then also we measure it against the business case. Is it still stacking up, or are we wasting money? Sorry. Enable. So trying to do this at scale also meant that we needed to think very deeply about what team structures we need, what roles do we need, how do we, should we be expecting a cybersecurity expert to be also an expert in machine learning or data science? And we realized we need to have cross-functional teams out there. Folks who understand data engineering, folks who understand machine learning, data science, paired up with cybersecurity experts, because they're complementary roles, they're complementary functions, in terms of achieving that outcome. By design, what we also have is an AI risk manager who is sort of in a partial capacity associated with pretty much every initiative that we are running. The next bit was about cross-functional collaboration. The implications of building these AI, cyber use cases and solutions also meant that we had to think about what are the implications from a legal perspective, what are the implications from a privacy standpoint. Is there a linkage of, for example, the identity-centric use cases? What's the linkage to HR? Would we be compliant to some of those policies that we have internally within EY and also for the clients that we work with? The next was about processes and workflows. Establishing MLOps, and some of you may be familiar with MLOps, but those who are not, for example, how do you ensure versioning of your machine learning models? How do you ensure that the entire life cycle of your machine learning model is addressing the life cycle of the use case or the solution that you're building? And we had to find and build processes which integrate MLOps, DevOps, the security ops, and at the same time also look at the AI guardrails that we need to bring in. Next bit is about training. And I have twins, a boy and a girl. My boy, he's just about 2 years old now, and he seems to like airplanes a lot, and he keeps saying, "I want to fly an airplane. I want to be, I'm a pilot." Is sort of what he's trying to do. And the argument that my wife and I have is, by the age of 5, this guy needs to know data, data engineering. He should be probably good at differential calculus. How the hell is he going to fly an airplane? Because when he grows up, he's not going to be flying the plane. It's the AI models and the machine learning models, et cetera, which are essentially going to be flying the plane. He's going to be tuning them. And sorry, I took a slightly different, exaggerated example, but this is true story. I did have this fight. But it's important to understand how we are training people in our organization as well. And think about the past 4 months, right? We've had MCP come in. We have started talking about agentic AI, and the rate at which the technology is evolving is just too fast, and we have to create that mechanism of ensuring people are kept abreast with what's the latest and greatest out there and being able to use it. There's a dimension of culture as well out here, and culture, I think I'll try and link this to an innovation culture. And when you say innovation culture, it's important to also recognize that there will be failures, and you have to also promote that experimentation within the organization. Of course, linking back to the business case for sure. Every initiative cannot be an experiment and cannot fail, but you have to create space for failure. And that's a bit of a cultural element as leaders we need to think about and groom and build in our organizations. So there are few, and we had lots of pitfalls, but here are the main ones, right? Data quality and the amount of data by far is the biggest stumbling block. There may be great ideas, but without the right data and the right quantity of data, it is very challenging to see any form of value from an AI perspective. The second bit is there's this notion that, you've built an AI model and it should suddenly plug and play into your security infrastructure and your operations, which is a fallacy. You have to think about it's not going to work because there's a lot of other stuff that you will also need to sort of change in terms of processes and so on before you start seeing value in the continuum, right? Because AI is not living in an isolation out there. It has to be interconnected with other things. This next one is also an interesting one. Some of the initial work that we did was, we had teams working on AI cyber initiatives. They built these models, but those teams were actually working in silos. They very rarely went back to the consumers of this. And I remember this very interesting AI use case, which was intended for security operations. Money was spent. Everyone celebrated, we built something. And then 1 year down the line, we saw that nobody was using it. We went back to find out why. Why is no one using it? And one of the things that we recognized was that no one actually, or the analysts didn't trust. And they weren't able to understand the or explain nobody was able to explain what the AI models were really doing out there because of that lack of miscommunication, so to speak. There's another dimension. The next one was about data bias creeping in. For example, some of the analysts who are more endpoint-centric, invariably what we tend to see is that they tend to build AI models which are AI-centric or endpoint-centric, and it's important that you don't land up in that scenario where your machine learning model is biased in a certain direction, right? And that's the point around data bias. And lastly, adversarial attacks on AI. Now, AI, we are trusting it a lot. When it goes into production, it's intended to work autonomously. But what if the AI model itself is attacked? The impact is catastrophic. And that's another dimension of testing these models in sort of, in a smaller scale before you start introducing them into production. I'm going to cover this very quickly because this is sort of linking back to the earlier point, but when we think about deployments, we start with our quick wins. What we tend to see is that after the quick wins, we typically focus on strengthening the data and the infrastructure around it. We also look at, expanding the use case from beyond, let's say, the detect domain into more prevent domain and so on. We also then look at, and then it's about taking that into full production and continuous improvement. Out there, think about it as more as an evolving product because these models will need to continuously be fed with new data. They also need to be kept updated, and that's another very important dimension. And lastly, it's about what is the broader application of that? Can something which has been created for cyber find use cases in other scenarios? So as an example, we have built an AI model which does threat response prediction. It basically helps analysts it provides recommendations that here's what you need to go next based on the threat scenario. And when we discuss this internally, one of the things that we realize is that has a direct application also in FinCrime, where we support a number of our clients. So I'm going to wrap up with this. I won't cover this. I want to leave a few minutes we have about 3-4 minutes for any questions that you might have. Please.
Yes. With businesses having different tolerances to risk and compliance, how do you reconcile that with the ever-growing expectation to get things released faster and quicker into release?
Great question. I spoke about cross-functional collaboration earlier, and one of the things that we do out there is have an AI governance function, which is essentially looking at various aspects. And that is also a mechanism of expectation setting. That how do are we taking too many risks in the interest of trying to get ahead, right? And before you release something into production, because we recognize that it's as EY, I mean, we use, we eat our own dog food, but we also work with clients. I mean, if we introduce stuff which is going to impact our clients negatively, that's got reputational damage for EY, right? So those are lots of decisions which we make as part of that. And we had to create this specifically and separately, I mean, over and above the existing risk management processes that we had. Does that answer your question?
Do you have any other questions? Question at the back there.
Sure.
I'll just project the slide. Thank you. Good morning. The slide that showed the calculation, the quantitative, we're saving X in labor, et cetera.
Yep.
That's all quantitative, and it's
Yep.
Very palatable for the C-suite.
Yep.
But equally as impactful is some of the qualitative stuff, like the reputational damage that could affect the organization should some of this stuff not get implemented. So how do you recommend best conveying that risk that is more qualitative before it gets to the point where it's quantitative, meaning after it's affected the business? Thank you.
Was your question predominantly about avoidance of something bad happening?
How do you recommend best conveying the risk equally and as easily as just showing a calculation to the C-suite?
So, great question, and I don't have the perfect answer for this. But what we realized was that when we started looking at those avoidance sort of scenarios, that's a very debatable space to be in, because we will prevent X kinds of attack, for example. It's very difficult to quantify that. It's not happened. And we realized that we should probably, it should be, I mean, this is not the only statement in the business case. It would be qualitative aspects as well. But for management to make that decision, we needed something which was a little more concrete, and we sort of agreed on this, because I'm not allowed to tell you how much money we burnt. My colleagues and I, we can have a sidebar on that later. But we didn't want to. We wanted to make sure that we are not burning money with hazy, fuzzy business cases around it. And we deliberately decided not to include it in the main business case statement, and because the value that we're looking at is more in terms of improvements. What are we going to improve? That's where the value dimension comes in. I know it is quantified, but and there are times where we struggle to even articulate what it actually means. So, very valid question, but internally within EY, we made that decision not to go down that path.
All right, well, thank you very much for your presentation, Kirti, and give a big round of applause. Thank you.
Just one last thing. We'd like to continue this conversation with you. So if you are interested, if you're dealing with a problem, do see us at our booth, D42. My colleague Jose, Javier, we're all there. And we'd be happy to talk to you about this. Thank you so much.